Ladies and gentlemen, this Red Gaming Tentacom video, we're going to be discussing multi-core CPUs and why they're becoming so much more important, and as well as the importance of multi-threading. Most likely this is going to be the first of a couple of part videos because it's a pretty in-depth topic. So you may remember just a couple of days ago I released a video discussing the death of Moore's Law. Now, Moore's Law, as I'm sure many of you are aware by now, is the principle that the amount of transistors on a computer will double every 2 years. So it's starting to come to an end as various issues start to plague CPUs. Now, for a long time, CPUs have started to go multi-threaded. There are numerous reasons for this, and we're going to be discussing some of them in this video. Now, for a long time, decades actually, CPUs, processors in other words, followed what was known as Dennard scaling. Now, Dennard is D-E-N-N-A-R-D. And Dennard scaling was actually what gave Moore's Law the real kind of bite it needed to become a law. And the idea behind this was that various issues such as, say, the transistor length, the size basically of them, and various other factors could all be scaled constantly. Now, we're starting to realize that this is no longer the case. Now, it's little known, but the 1990s, in other words, the 90s, were often known as the golden age of computing in terms of the improvements. And some would even say the golden age of scaling. That's what some people refer to it as in the industry. Why? Well, quite simply put, the improvements in the 90s over CPUs in terms of how they were scaling, in terms of transistors, including, for example, the CPU frequency and so on, was massive. We went from a time of the 8086 to the Pentium 3, and the Pentium 3, of course, the 1 GHz drew about 33 watts. So you were getting power consumption increases of about 18 times. CPU frequencies, meanwhile, were going up 125%. And that's not even including other things which make and improve CPU speeds. For example, caches, level 2 caches, out of order execution, various other improvements as well. All of these go together to form a much better processor. As I'm sure you're aware, you can only really judge a CPU clock speed based upon the same processor family. So in other words, let's assume that you have a processor and your friend has exactly the same model processor, but his is, say, 200 megahertz slower, just for example. Then your processor obviously is a little bit faster. That's fairly simple. So what the hell was happening? Why was all of this starting to come into effect? And why is it now that we're starting to get issues? Well, it goes very simply. When you start to reduce the manufacturing process, you start to get issues of leakage. And basically what happened is when you hit the 90 mm threshold, you started to get leaking. And to really illustrate this, let's talk about a couple of years ago. CPU clock speeds, and this is including turbo mode, for example, from, say, some of the high-end Intel processors. You'd be going from just under 3 GHz, about 2.93, to just under 4 GHz, 3.9. That's pretty impressive, right? I mean, you know, it's pretty decent. That's 33% increase in performance. Not shabby at all. You know, not bad. 4 years, 33%, not bad. On the other hand, those who remember the early 90s and early 2000s, you'll remember that clock speeds seemed to just increase exponentially. We had processors, for example, of 66 MHz, 33 MHz, 150 MHz. In fact, it was so great that from 94 to 98, you actually saw CPU speeds increase by not 30%, not 50%, not even 100 or 150%, but 300% increase in clock speed. So, what's the solution? Well, there are numerous solutions. One of them is multi-core CPUs. Now, I'm sure you're familiar with them now because, well, you should be. Any modern day gaming console, for example, the Xbox 360, the new PlayStation 4 that's coming out, most modern desktops, in fact, pretty much any desktop now, or laptop for that matter, is going to have a multi-core CPU. Just how many CPUs you've got really depends on, of course, how many CPU cores you've got. Really depends on the type of CPU that you've got. For example, you can get dual-core CPUs, tri-core CPUs, quad-core CPUs, and all the way above. And the basic premise is that the workload is split over multiple cores. Some people may remember the early adoption of multi-cores, and this was back in, say, the E4300, E6600 era. This was back when Intel were really pushing the multi-core gaming idea. AMD had done some bits themselves with the X2 range, which was socket 939s, for example. But they weren't really the norm. They worked for certain, programs, for example, Photoshop or say Adobe Premiere and whatever. But they were mostly for business applications because games themselves hadn't actually been written to take advantage of it. In other words, the game's engine wasn't really built for it. So what started to happen is you got this era where games slowly started to become optimized for multi-core processing. And it's not just simple. It's not just saying, well, okay, this processor has, 8 cores. Okay, well, great, there you have it. It's not. And this is one of the reasons now that we're starting to see an improvement in game multithreading, because consoles are starting to do it, so it makes sense, of course. Game multithreading and multithreading as a whole really depends on just how the game is split. For example, sometimes you have 1 to 2 really heavy threads, and other threads are not really so intensive. They don't really make full use of the CPU cores. So for example, what you can have is you could have 1 or 2 cores working at, say, 90%, just for example. On the other hand, let's say you have a quad-core CPU. So you've got 2 cores, just for example, working at 80 to 90%, right? So pretty much flat out. On the other hand, you could have another 2 cores which are working at 50% or 40%. Why? Well, it's just the way the game's engine has been designed and from the ground up. I remember back in the day, I was having a large argument with a forum guy. I'm not going to mention the forum. Don't really frequent it anymore, but I had this really large, massive argument. It was like several pages. I don't normally argue on forums, but this was just one of those instances where I was just like, I just didn't believe he was right, and he was giving system building advice to someone else, and this is one of those someone's wrong on the internet moments. I must write this. And the guy was trying to give building advice to someone else, and he was saying back then that the best processor to go for was the E8400. And I said, no, don't go for that processor. Go for a Q6600 or something similar. Make sure you get the Go version, the G0, and you'll get good overclocking. The argument was simple. He argued that the E8400 would be better overclocking. In other words, it would achieve a higher clock speed. It was faster out the gate. And so applications back then were only really dual core. On the other hand, I argued that, Windows does a really decent job, for the most part, of splitting basic applications and tasks to multiple cores. I argued that most games are going to be really reliant on the GPU anyway, but certain games, for example, Grand Theft Auto 4 at the time, Alan Wake, which ended up being delayed, but there were other titles as well, were starting to take advantage of quad-core, and I argued that, especially since this guy also wanted to do some desktop work, I believe his requirement was Photoshop, it just absolutely made no sense to me to go with the dual-core route. Anyway, the argument went several pages, shall I say, and eventually the person who originally created the thread, the person I wasn't arguing with, the person we were trying to advise, decided to go my route. Lo and behold, I actually had the Q6600 myself. Lo and behold, several months later, other titles started to be released which took advantage of multiple cores. Guess what happened? That's right, the guy that I originally gave advice to had to upgrade his CPU because titles were becoming more and more and more multi-thread orientated. However, he was right in one respect. More CPU cores does not equal to linear scaling. This is very similar, by the way, to the same issues of the Xbox One versus PlayStation 4 extra GCN cores. Sometimes things are more sensitive to higher clock speeds, for example, just because of the way they are not too good at paralyzation. Now, a program, an application, really relies on what is known as serial code. And that itself can only be executed on one processor. Most games and so on now are starting to have multiple hardware threads, but what they'll do, they'll have a single worker thread which really pushes and organizes what's going on in the other cores. Now, this is also known as an orchestrator. The idea is that tasks will be scheduled and then they will be parallelized over every single core available. So in other words, you can think of it this way, and this is simplifying this of course, but it would be pretty much that one processor does all the work, or one core does all the work in terms of, okay, this one goes to this core, this one goes to this core, this one goes to this core, and it organizes, prioritizes, and schedules the work respectively. Now, sometimes you'll get processors, say, like AMD's Bulldozer, which of course is a desktop processor from AMD, who are of course also responsible for the Jaguar, which resides in both the PlayStation 4 and the Xbox One. Now, the Bulldozer was considered to be, by many, lower performance than what you'd expect. There are a couple of reasons behind this. Primarily, it was a clock speed. Now, things such as, for example, caches were actually shared, and the idea behind this was to allow there to be more cores per processor. So, in other words, they would have a processor, and their plan was to stuff in more CPU cores into it. However, because of this, there was a higher power consumption, and this basically limited the maximum clock speed. There were also other issues such as slow cache, and this also reduces the amount of instructions, in other words, the amount of data that is ready for the processor itself, the CPU, to actually, well, process, right? Faster cache and a larger cache is generally preferable because it increases the chance that there is data in that cache that is available or is the right data. In other words, it increases the chip's hit rate or the cache's hit rate. And that's obviously a really good thing. So all of this limits what is known as the IPC. IPC also stands for instructions per cycle. Now, game engines such as, for example, id Tech 5, that's ID Tech 5, which of course is used on some of id Software's games, for example, Rage, the new Battlefield titles like Battlefield 3 onwards, and a lot of other games besides, I'm certainly not going to be going into all of them, are all reliant now on multi-core technology. Just for example, and one of the reasons that I told that story earlier, you may remember that I was talking about Grand Theft Auto 4 on the PC. As it turns out, GTA 4 on the PC ran like a dog on a dual core. It didn't really matter what the clock speed is. It actually turns out that a lower clock speed CPU that was quad or tri would actually give a much better performance than a higher speed in terms of clock speed dual core CPU. Why? Well, pretty simple when you think about it. It was designed for consoles, and so there was a high level of parallelism. Because of this, there were multiple threads that really wanted to be used, and otherwise you're basically forcing them all onto the same CPU, and that's not really ideal when you consider just how many jobs are being allocated towards the CPU. So there are multiple different issues that the CPU is dealing with. Now, as it turns out, in the future we're going to be looking at situations where a lot of stuff is starting to be offloaded to the GPU. right? The graphics processing unit. And there are reasons behind this, including the processing units inside just much better lend themselves to parallel computing, right? We know that the Xbox One and PlayStation 4 are going to enable this with the compute units. Most desktop processors can do that as well, for example, modern day NVIDIA cards and so on. And there are reasons behind it. Right, we've spoken about some of them before, some of their tasks. For example, fluid and physics and whatever else. And remember, all of this comes down to the same thing. For example, if you're playing Batman Arkham City on the PC, and you have an NVIDIA card, you can enable hardware physics. And it's not just about, say, a bunch of leaves blowing about. You'll notice that even things such as Batman's cape, which, by the way, actually had an artist all to himself. It actually had an artist just working on Batman's cape. Pretty interesting job, I imagine. But even the cape has more details. And all of those, if you're not using NVIDIA's, physics, they have to actually be done by the CPU. So there are so many different details that you're not really expecting, for example, grass and leaves and object collision and much more besides. I remember one issue I have with, say, Far Cry 3. It's a beautiful looking game, I'm not going to dismiss that. It does look really awesome, but I have some really massive issues with object collision and on the game. I'm sure many of you have played it by now, but it's not a spoiler or anything, so don't worry. But if you go into a vehicle in that game, drive into a grassy area and look down into the well where your feet are in the car, yeah, you can see it, right? The grass sticking up. That's a huge pet peeve of mine, and it's just something that you can just tell that, there were some issues with it, and it's really annoying. I really hate that. It really destroys the immersion for me. Things such as collision detection, in other words. Things such as cloth simulation, transparency processing, for example, for foliage, or for, say, water effects in some cases, or particles, or whatever. All of these different things are key. All of them require a lot of processing power. I mean, obviously it depends on the levels of detail on that particular game. And you may remember, I've said a couple of times previously that it's going to take a long time for the next generation of consoles to really make full use of the hardware that's available. This is the same as the PC. Generally speaking, it's a hell of a lot easier for hardware developers to put something out than what it is for software developers to make full usage of it, because it takes time for their tools to get good enough for them to get enough knowledge. Software and hardware really have to come together to form the whole. It's not just simply one thing. And new engines, of course, have to be built from the ground up in some cases to really take advantage of this. Now, I'm sure many of you right now are automatically screaming things such as compute, such as APUs, such as whatever else you can think of, but all of these things come together. But ultimately, first of all, not all stuff can be put on to GPUs to compute. Secondly, it doesn't break Moore's law. It doesn't stop Moore's law from happening, and we know that Moore's law, from what Intel themselves have said, is likely going to be dead within 10 years. With multi-core, you still have issues such as power, such as parallel scaling, and scalability as a whole. We are, however, fairly early in multi-core technologies, and some companies are pursuing what's known as wimpy cores. We'll go into that in another video, however, because it's quite a big topic in and of itself. Heterogeneous compute, such as APUs, which of course are going to feature heavily in the Xbox One / PlayStation 4. And if AMD have their way, desktops as well, combined with a discrete GPU, so we understand, they have their own issues. We know, of course, that they do have abundant data parallelism, so they can, compute a lot of stuff. GPUs inherently are very power efficient. However, there are some issues. One, for example, is programming as well as the communications overhead. So in other words, data passing backwards and forwards, there definitely has to be a good, robust bus system for that. The Xbox One and PlayStation 4, as far as what we understand anyway, do have really good communications between the GPU, the CPU, and both systems, including the Xbox One, do have a certain amount of coherent memory. The Xbox One, for example, has 30 gigabytes per second of coherent memory, and the reason behind that is simple. So that the Xbox One's CPU, the Xbox One's GPU, both know what the hell's going on, and both can process data. So in other words, they can pass the data backwards and forwards, so there doesn't need to be copying operations, for example, certain pieces of data. Obviously, if you copy a piece of data, well, you can imagine what happens. You have to factor that copy operation in. That takes both CPU cycles, that takes memory cycles, and also, of course, you're basically, for a certain amount of time, actually having multiple copies in the same piece of memory, which isn't really good. It's not an ideal way to work, is what it basically comes down to. So as it turns out, we're going to be looking at much more coherent memory. It depends really what's going to be happening, because each developer, everyone is really trying to push their own way. Each person is trying to strive forward. But ultimately, of course, we're still really early in this. We know organizations such as DARPA, that's DARPA, are working on technology to try to claw back Dennard scaling / Moore's law / everything else. But we're still really early in this, and I think it depends on just how well we are starting to progress forward. Games at the moment are definitely going to take advantage of multiple core CPUs. I remember there were various interviews going about which showed just how much Intel classically batter AMD in terms of game performance, right? We're talking about for CPUs. Why? Well, it's because AMD have gone the more multi-core route, which, as it turns out, has some advantages for certain games, but primarily, generally, because games don't really require that many hardware threads yet, and I emphasize the word yet, what typically happens is that because AMD's CPUs are slower per core, they've got lower clock speeds, they don't handle so many IPCs, whatever it is, depends obviously on the make and model of both chips, there can be issues. So, in other words, per thread, per core, you might get an issue where Intel are faster. This basically means that because there aren't so many hardware threads anyway, in other words, it's not very well parallelized, the game, you simply get issues where Intel outperform AMD. However, certain titles, for example Crysis 3, happen to be really good at multi-core systems. And so you're getting cases where high amounts of cores on processors, on CPUs in other words, are starting to claw back performance from Intel. And that's why we're really starting to see the era of multi-core processors. Obviously, things are still really early at the moment, and it's gonna change. Things really are gonna start changing quite significantly. Obviously, AMD have released a 5 GHz processor, which obviously makes quite a bit of difference. However, AMD are still losing to Intel in terms of generally per core. Obviously, AMD are working on their own new architectures to release for the desktops. And that's the important thing, because obviously there's always that disparity, that change, that difference between, say, a low power device like, say, a laptop. Or no, not actually, a laptop's not even a great example. Let's even use something like, or a smartphone or a tablet device, compared to, say, a full-blown desktop. And that's because power doesn't matter so much. Nvidia, who of course are a pretty well-known figure in the GPU industry on the computing side, they've said, look, within a couple of generations, the Xbox 360 and PlayStation 3, we're going to be able to put this on our smartphones. And this is true. We probably will, but the problem is, of course, power to run it. Yeah, that's a massive issue. the actual power to run things is quite massive. I mean, now we have, cell phones that just look how powerful they are. You can have cell phone emulators that can emulate, like, Genesis and SNES and whatever else really easily. You can have smartphones now which are really powerful, but there are problems with their cores, and I'm not going to go too much into it, but even John Carmack has said this before. There are issues with full access to the performance of the cores, there are the inherent inefficiencies with the Android operating system, or in some cases even the iPhones as well, the iOS operating system, same deal really. This isn't my words, by the way, this is John Carmack, and I'm pretty sure you'll agree the man knows quite a bit about computing. So there you have it. Anyway, that's just about it for this video. There's some more stuff we need to talk about, but unfortunately if I start breaking into the topic, it's going to pretty much open up a huge can of worms, and I'm going to have to start explaining a lot of stuff. And so you can look forward to part 2 at some point in the next couple of weeks, hopefully maybe the next week if I can manage to wrangle it out. I'm pretty busy at the moment, but hopefully you guys have enjoyed the video. I will see you soon. Take care. Bye for now.